Hi there. We're going to talk about solids this time. Back in 1985, chemists came up with this cool way of taking carbon and um, changing it into this round buckyball thing. And so we're going to talk about how solids are arranged and some general properties about solids. So this is a really cool thing. They're trying to use this a lot in new applications. So chemists always do that. They try to make cool designs out of chemicals. So how are the structures and properties of solids related to each other? So the properties of solids are reflected by their orderly arrangement. So they like to stay, each nucleus wants to stay in one place and not move too much. So all molecules and atoms move. In gases they move the most. Solids are the least, and liquids are the medium amount of movement. So in general, these particles are just sitting in one location and not moving around. They're vibrating a little bit, but they're not moving. So melting point is the temperature when the solid gets enough kinetic energy to change into that liquid phase. Liquid, the atoms are still touching each other and moving around slowly. But they're still touching each other. In gas, they have enough energy to bounce off of each other and go into the gas phase. So that's the difference between the three. So if solid gets enough energy from not moving, and they get enough kinetic energy, they're still touching. They're touching a solid, and they get enough energy, they can start moving on top of each other, okay? And that is a liquid, okay? So, and then if they get more energy, then they're going to bounce off into the gas phase. Okay, so that's all the difference between these things are. Solid is touching each other, not moving very much, vibrating, but not moving very much. If they get more energy, they start moving around and against each other. So that's a liquid. So melting point is changing from solid to liquid, and freezing is changing liquid to solid. What determines the shape of these crystals? Crystals are how the atoms are set in a particular shape, like that buckyball thing I showed you. In a crystal, the particles are arranged in a repeating pattern. And you see here there's one chlorine surrounded by all kinds of sodium, one sodium surrounded by chlorines, and it's a nice repeating pattern. It stays the same. That's a crystal. The shape of the crystal is based on those particles, how they're set up, and the size of each piece, each atom or ion inside that. So crystals have different shapes, and they have some of them have different amount of faces. So faces is just this one side. So for example, this top is a face. So galena has this nice cubic shape. If you took some salt from your kitchen and looked at it under a hand lens or a microscope, you'd see it's also little squares. You might be able to see it with your just your eye. So salt likes to be in this cubic shape. Zircon likes to be in a more of a rectangle block. And then topaz has its own shape. So all of these are telling me the angles that these faces meet at each other at each corner. There's 7 different kinds of crystals, and here's some more. And so minerals and rocks have these shapes, and it's based on the particles and how they're stacking onto each other. So the smallest group of particles within a crystal is called the unit cell. And we said there's different kinds of unit cells. I just showed you those. So there's 3 kinds of unit cells that can make up a cube. You can have a simple cube like this. You can have one little atom inside or ion inside this. That's called body-centered. Or you can have little atoms or ions that want to be on the faces of the cube. So that's called face-centered cubic. Allotropes are 2 or more different forms of the same element in the same physical state. It's because the particles arrange themselves in a little bit. They stack in a little different way. That's an allotrope. And they have different properties because they're stacked differently. Only a few elements have these. So here's allotropes of carbon. Remember, this is the buckyball we said. We can form this into this beautiful 60 atom sphere with a hollow center that chemists made. We can also have graphite, so if you are using a mechanical pencil or a regular pencil, you're using this graphite, and so it's got long sheets of carbon put together on top of another sheet, and because you're pressing down on your pencil, those sheets are separating from each other, and one of the sheets is staying on your paper. Diamond is set up like this, and it's very rigid because of its structure. So you know diamond's very strong. Graphite's not strong because we can write with it. So it just depends on how the atoms are bonded together and then how they're set on top of each other. So an amorphous solid is something that does not have that beautiful structure we've been talking about. Glass is an example. The molecules are just kind of just packed randomly together, so that's an amorphous solid. And so glass is not a crystal. We think of glass because it's transparent. It's like crystals of diamond and things like that, but it doesn't have a particular structure of those molecules on top of each other. So let's see how much you learned about solids. Quick section. A solid will melt when... What do you think? So a solid's going to melt when the vibrations that you're giving it with kinetic energy are overcoming how much attraction those molecules or atoms have for each other. So which affects the shape of crystals? So take a look at those. So 1 and 2, the angles of how those faces are affecting each other, and then the number of edges is going to show you the shape. And allotropes, what are those? So they have different properties. Even though there's the same molecule or atom, they're different, have different properties because they're arranged differently. So arrangement of the atoms or the molecules in a structure really affect the properties of that structure. I hope you learned a little bit about solids, and I'll talk to you soon. Have a great day.